Okay, good morning, grade 9. So today we're going to do a short little lesson and we're going to look at properties of ionic compounds. So ionic compounds, because they're joined by charges, have a relatively strong bond, okay? And this creates them to have high melting points. So our first point is that they have high melting points. That's the first property. High melting point. Okay. We also know that think about your salts, your copper chlorides. Remember we saw the substances at the beginning of the year with the blue crystals. Those are all ionic compounds. So most, because remember in chemistry, unfortunately, there's always a lot of exceptions. So most ionic compounds are in crystal structures. So they're in organized crystal structures. Compounds are in crystal structures. And they show you these examples on page 205. So take a look at the examples that they give you are in crystal solid structures. We then go on to talk about the coordination number. Now, what I want to express with you is I'm never going to ask you at this stage to figure out the coordination number. Okay, you just need to know what it is. So the coordination number in your textbook says the coordination number of an ion is the number of ions of opposite charge that surround the ion in the crystal. Okay, so we want to know how many ions of opposite charge surround our other ion. Okay. And please look at the example on 205. You're not going to be expected to figure that out at this stage. You just need to know what the coordination number is. But what I really do want to go through today, so I'm going to write this all out. So we have one property we have not figured. So the first property was what? High melting point. Second property, that they are crystalline solid states. But it is important to know that ionic compounds are pretty cool because they can conduct electricity. Now, they can only do this once they have dissolved. I'm going to explain this now. So they conduct electric current. And remember I said this is pretty important for us, for our existence. That's why we are mainly water, because we want to conduct electricity through our bodies in order for us to function. So we're going to look at a cup of water, okay? So in this cup of water, we're going to look at sodium chloride. For those of you, you know sodium chloride is our table salt, okay? And sodium chloride has a formula like this. We're going to say the black is our cation. Remember, cations always come first. And our red is going to be our anion. So what happens, remember at our second point, they form structures, right? They form crystalline structures. So what we're going to do is we're going to draw the crystalline structure in here. Okay, so I'm just going to do this. I'm going to do a quick one for you guys. Okay. So obviously it's a lot more. I'm only doing 2 rows, but it's usually a perfect square. So let's actually do that now, just so you guys can get the idea. Okay, so that is our crystal structure. Okay, what happens now when I add water or I add the salt to the water? What actually starts? So don't forget, hey, these are positive, 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 negative, negative. Now, these are all ions that have joined to form an ionic compound. So when we put water in, what starts to happen is our ions start to break away. Okay, they're pulled by the water, but you don't need to know that just yet. They break away. Okay, and when it is fully dissolved, all of these ions have now become free. So what they end up looking like Sorry, my cup is a little bit of a disaster. Let me just fix it. Okay. What it ends up looking like is it ends up having free floating ions. So it's no longer an ionic compound. It's free floating ions. Okay. So when it goes into water, it becomes free floating ions. This is why it conducts electricity. Because if I had to add a charge, okay, an electric current, they are free floating ions. So we know the positives are now free to go through the current of the negative side, and our negatives are free to go to the current of our positive side. That is why ionic compounds are good conductors of electricity, because they can break apart when dissolved. Molecular compounds do not break apart into individual ions. They stay in molecules. This is a little bit advanced for you guys, but just for some extra general knowledge for those of you that are curious. So the final point is that ionic compounds can conduct an electric current. Please look at the image on page 206. It also explains this. Okay, guys, have a good day.